Hello everybody. Today I'm going to be talking about the determinants of 2 by 2 matrices. We have two objectives. The first objective is to calculate the determinant of a 2 by 2 matrix, and the second objective is to explain the meaning of a zero determinant. That is, explain what it means when a matrix has determinant 0. So let's get started. So to calculate the determinant of a 2 by 2 matrix, all you need is one formula. All you have to remember is this minus that. That is, the determinant of this matrix A, B, C, D is AD minus BC. That's the only formula that you need to remember. So let's do an example. Here we have the matrix 1, 2, 3, 4. If I want to calculate its determinant, I just need to do 1, 4 minus 2, 3. That's 1 times 4 minus 2 times 3, which is equal to 4, minus 6, which is negative 2. So the determinant of this matrix is negative 2. All right, let's do this example. For this determinant, we just need to do, again, that minus that. That is, we have 3 times 12 minus 6 times 6. This is 36 minus 36, and it's going to end up being 0. So this matrix has a determinant equal to 0. This guy, the same thing, but now we have a negative sign. So we're going to have this minus that, looks like 2 times 4, minus 4 times negative 1. 2 times 4 is 8. 4 times negative 1 is negative 4, but we are subtracting a negative, so this ends up being 8 plus 4, we get 12. It's always easy to make a mistake if you have a negative number in your matrix and you're subtracting that negative number. You have to remember to make it positive. It's an easy mistake to make. I've done it many times. All right, so for this last one now, we have this minus that. That's 1 times 6 minus 2 times 3. We've got 6 minus 6, and we get 0. All right, so now I'd like to talk about these two matrices. As we can see, when we calculated the determinant of these bottom two matrices, we got 0. And there's actually a very specific reason that that's happening. So if we look at this matrix, if we look at column 1, we have 3, 6. If we look at column 2, we have 6, 12. And actually, if you look closely, the number right here is always 2 times the number right here. 6 equals 3 times 2. 12 equals 6 times 2. So you could say that column 2 of this matrix is equal to column 1 times 2. You could go the other way, though. You could say, I have a 6 here, and 3 is half of 6. I have a 12 here, 6 is half of 12. So I could also say, column 1 equals 1/2 times column 2. If I were to look at the rows, I would see something similar. This row is 3, 6. This row is 6, 12. Row 2 is 2 times row 1. I can squeeze that here. Row 2 is equal to 2 times row 1. And I could say that the other way around and say row 1 equals 1/2 times row 2. Let's take a look at this other matrix. We're going to notice the exact same thing. Here, let's look at the columns first. This column here, column 1 is 1, 3. This column here is 2, 6. So again, we can say column 2 is equal to column 1 times 2, or column 1 equals 1/2 times column 2. And if we look at the rows, we're going to notice the same thing. This row is 1, 2. This row is 3, 6. To get from here to here, we do times 3. Here to here, we do times 3. So we have row 2 is equal to row 1 times 3. And alternatively, row 1 is equal to row 2 times a third. Okay, so what's the general rule for when a matrix that's a 2 by 2 matrix has a 0 determinant? Well, it's if any of these 4 things happen, and actually if one of these things happen, they all will happen. What I mean by that is if you have column 1 equaling column 2 times some number, let's call that number A1, or if column 2 is equal to column 1 times some number, let's call it A2, or if row 1 is equal to row 2 times some number, or if row 2 is equal to row 1 times some number, any of these things happen, then the matrix will have determinant 0. And actually, if one of these things will happen, we can see from these examples that all of these things will happen. So for 2 by 2 matrices, that's what it means to have a determinant 0. Thanks for watching. I hope to see you again in my next videos.